Welcome to this short video tutorial on how to install and use the R script provided as supplementary data 2 of the paper published in Journal of Analytical Toxicology. This script will allow you to correct for the endogenous concentration present in a spiking matrix by using the real analyte concentration actually present in the calibration matrix to build your calibration curve. So the first step is to install R and RStudio on your computer. R is an open source programming language and software for statistical computing. It can be found free of charge at r-project.org. To install it on your computer, you need to click on the CRAN link under the download section of the left-hand side of the website. CRAN, which stands for the Comprehensive R Archive Network, is a list of different servers or mirrors that contain the R software which you can download. So choose one of the mirrors, click on it, and then you can install R on your computer by selecting the appropriate version for you. Well, RStudio can be found at rstudio.com. It is a graphical, user-friendly interface for coding in R. So to obtain RStudio, simply click on Download RStudio, and then you can select the free open source edition of the software. A commercial licensed version of the software exists for those who are interested. Well, once R and RStudio are installed on your computer, you need to download the R script titled Endogenous correction.r. If you don't already have it, a link to Dropbox for download is available in the description of this video. So you will now need to set up the R environment. So you need to open RStudio. The first necessary step is to install a package called dplayer. So in the bottom right panel, in the Packages tab, click on Install. Then you need to search for the package called dplayer and launch the installation. Since the package is retrieved on a website, you must have an internet connection for the installation to be successful. Once the step is complete, a line will say that the package was successfully unpacked. Okay, so let's now take a look at the only script you will need to work in, endogenous correction. So I will go on my desktop and open the script in RStudio. Okay, when you open it, you see in the header here that there are a number of parameters which need to be set by the user. So the first one right here is the working directory. So the directory tells RStudio where to retrieve files, drop results, and just generally operate the whole process. The easiest way to find the working directory is to place your cursor in the console down here, the bottom left pane. You then click on the menu Session, Set Working Directory, choose Directory. Then you can browse for the folder containing the R script. In our case, that's the desktop. Here we go. And I just select the folder. Okay, so the working directory is now set here inside the console, but it also needs to be defined inside the script that's right here. So the easiest way to do this is to take the path that's here in the console and hit Ctrl+C. And then I can just copy that line in the script right here, Ctrl+V. Okay, so then the directory is properly set. So the next parameter that needs to be set is weighting, right here. So you need to indicate which weight should be used in performing the regression. No weight, 1/x, or 1/x squared. We suggest here that you use the weight selected during the validation process, the one used in production to build the calibration curve. So write either A, B, or C right here. And it's very important not to remove the quotation marks. So A, B, or C needs to be inside quotation marks. Next, on this line here, the calibration order needs to be specified. Do you wish to use a linear or a quadratic calibration model? Again, we suggest that you use whatever was selected during the validation process, what's been used in production. So write L or Q inside the quotation marks here. So I've selected Q for a quadratic model. Okay, all the parameters are set now, and we can save the script. So we're ready to perform our correction operations now. So I'll give you an example of how this works with a BHP dataset we've acquired on an LC-MS system. Unfortunately, since I can't record this on the laboratory's computers, IT rules oblige, I will not be able to show you how to treat the data in the real software. I'll show you a dataset copied straight from Multiquant, but in an Excel spreadsheet. So let's go and open it. Here we go. But know that any data analysis software that allows you to copy data and paste a series of corrected concentration will do just fine with this script. We've tested Multiquant and Mass Hunter, and it works just fine. Okay, so let's go in our data analysis software where the batch is opened, or in this case, our Excel spreadsheet. I need to display the standards and quality control samples only, and then I select the concentration and area ratio columns only, right here. Now I hit Control-C to send all of this data to the clipboard. Note that I only select the data, not the header of the columns. The script won't work if the header is used. Okay, now that the data is in the clipboard, I just need to go back in RStudio and I hit Source. And there we go. All the calculations have been automatically performed, and the corrected concentrations reflecting the real analyte concentration present in the samples are sent to the clipboard and are ready to be pasted. You even have a short message in the console here confirming that everything went well. Okay, so the last step is to go back in your data analysis software, or in our case, the Excel spreadsheet, and we need to paste those corrected concentrations by hitting Control-V. And there we go. The calibration curve has been shifted, as you've just seen, and it's not more complicated than that. So this is how you use the R script to perform the endogenous concentration correction. If you have any questions or issues, don't hesitate to write me an email, and I'll do my best to help you. Now you can go and have fun with your own data.